The first question says the equation of a curve is such that dy by dx is 4 upon x minus 3, the holding cube. The domain for the question is x greater than 3. The curve passes through the point 4, 5. We need to find the equation of a curve. To find the equation of a curve, when you are given a dy by dx expression, to find the equation of a curve, you just need to integrate this. So dy by dx is equal to 4 times x minus 3 to the power of minus 3. To find the equation of a curve, we are going to integrate this function. So integral of dy by dx is y. You can take 4 common out of the integral sign. The integration of x minus 3 to the power of minus 3 is going to be x minus 3 to the power of minus 3 plus 1. Remember, you add 1 to the power divided by the new power. The new power is going to be minus 3 plus 1, that is 2, minus 2, plus the constant of integration. Y equals to 4 divided by minus 2 times x minus 3 to the power of negative 2 plus c. Now, to find the value of c over here, which is the constant of integration, we are going to plug in the value of a point. This is a point where the curve is passing. So you are going to substitute x as 4 and y as 5. And you are going to solve for the value of c. So c comes out to be 7. So the equation of the curve is y equals to minus 2 times x minus 3 to the power of minus 2 plus 7. This is the equation of your curve. So the second question says the coefficient of x to the power 4 in the expansion of x plus a to the power of 6 is p. X plus a to the power of 6. In this expansion, there is going to be a term that is going to be having a term in x to the power of 4. So that term is basically going to be 6c2 x to the power of 6 minus 2, second term to the power of 2. Because then only you are going to get x to the power 4 if you take the third term, which is going to be in the form of 6c2. So 6c2 comes out to be 15. So the coefficient is 15a square x to the power of 4. So in this expansion, 15a square x to the power 4 is a term in x to the power 4, and 15a square is the coefficient of x to the power 4. The question says that the coefficient of x to the power 4 in this expansion is p, which means that 15a to the power of 2 is equal to p. The coefficient is equal to p. Then it says that the coefficient of x square in the expansion of ax plus 3 to the power of 4 is q, which means that if I were to expand this, there is going to be a term in x square. Now, if you want x square over here, if you want the x to have a power of 2, you will go for 4c2, ax to the power of 4 minus 2, 3 to the power of 2. So if you resolve this, 4c2 is 6, 3 square is 9. That comes out to be 54a square x square. Over here, 15a square was the coefficient of x to the power 4. Over here, we have 54a square as the coefficient of x square. So 54a square would be equal to q as given in the question. Now the question says, it is given that p plus q is equal to 276. Find the possible values of constant a. So p plus q is equal to 276. P is equal to 15a square. Q is equals to 54a square equals to 276. If you add them, 54 plus 15, that's 69. So a square comes out to be 276 divided by 69, that is 4. And a would be equal to plus minus 2. Now, in question number 3, you have to express 4x square minus 24x plus p in the form of a times x plus b the whole thing square plus c. That is a completing square form. This is the general form of a quadratic equation. We need to express the general form into a completing square form. So 4x square minus 24x plus p is same as a times x plus b the whole thing square plus c. You can expand the right hand side. A times x square plus 2 times b times x plus b square plus c. Ax square plus 2abx plus ab square plus c. Now, if we compare the coefficient of x square on both the sides, coefficient of x square on the left hand side is 4 and the coefficient of x square on the right hand side is a. Therefore, a is 2. If you compare the coefficient of x on the left hand side, that's minus 24, and on the right hand side, it's 2ab. So minus 24 equals to 2ab. A is 2. So B is going to be negative 24 upon 4. That is negative 6.
Yeah.
And if we compare the constant term, my bad, A is 4. Just make a correction over here. A is 4 equals to 2 times 4 times B. B comes out to be negative 3. And if we compare the constant term on the left-hand side is P, and the constant term on the right-hand side is AB square plus C. A is 4, B
Yeah,
is minus 3 square, and
which would be P minus 36.
yeah, so that's going to be P. We are going to resolve this, and we need to express in terms of constant P. So C, P equals to 36 plus C. So C is going to be equal to P minus 36. So the completing square form would be A times x minus 3, the whole thing square, plus C, which is P minus 36. The second part says, hence or otherwise find the set of values of P for which the equation 4x squared minus 24x plus P equals to 0 has no real roots. So if we just use the completing square form, the completing square form would be 4 times x minus 3, the whole thing square, plus P minus 36. This is equal to 4x squared minus 24x plus P. This equation, when equated to 0, we need to show that we need to find the set of values of P for which this equation has no real roots. Then that means that if it does not have real roots, then the discriminant of this equation must be less than must be less than 0. So there are two ways of doing this. If we use the original form 4x squared minus 24x plus P, we use the concept of discriminant, and for this equation to have no real roots, the discriminant must be less than 0. So B square minus 4 times A times C less than 0. If we solve this, 24 square is 576 minus 16p. 16p is greater than 576. P is greater than 36. Okay, so that's the set of values of P. Now, if we were to use the completing square form, we would say that it's a minimum curve. And if you compare it with the general form, if you compare it with the completing square form, the coordinates of the turning point are 3, comma, P minus 36. The coordinates of the turning point would be 3, comma, P minus 36. Now, if we want this equation to have no real roots, that would mean that the curve lies entirely above the x-axis, which means that the y-coordinate of the turning point, which is this value, P minus 36, must be greater than 0. So if P minus 36 is greater than 0, then P must be greater than 36.
Yeah.
All right, now this question number 4 is basically on disguised quadratic because the powers of x are in the ratio of 2:1. Over here, the highest power of x is 6, and over here, the power of x is 3. So if in the equation, the ratio of the powers of x is 2:1, then that equation can be converted into quadratic form. So all you need to do is let x cube be equal to k, for example. So 8 times k square plus 215k minus 27 equals to 0. Now you get a quadratic equation in terms of k. You're going to solve for the value of k. You can use quadratic formula to do that. To do that, you're going to get two values of k. The two values are going to be 1 upon 8 and negative 27. All right. So if k is equals to 1 upon 8, then k was equals to x cube in the question. So x cube is equals to 1 upon 8 and x cube is equals to negative 27. To solve for x, we are going to take the cube root. X comes out to be 1 upon 2 and x comes out to be equal to cube root of negative 27 is negative 3. So these are the two values for x as the solution for this equation. Now question number 5 says the diagram shows the curve with equation y equals to 10x to the power of half minus 5 upon 2 times x to the power of 3 upon 2 for x greater than 0. The curve meets the x-axis at the point 0, 0 and 4, 0. Find the area of the shaded region. To find the area between the curve and the x-axis, you can integrate the function from 0 to 4 and integrate it with respect to x-axis. So area would be equal to integral of the function with respect to x, and the limits are going to be from 0 to 4. So function is 10x to the power of 1 upon 2 minus 5 upon 2 times x to the power of 3 upon 2. The limits on the x-axis are 0 to 4. So let's integrate this. Integral of 10x to the power of half is going to be 10x to the power of half plus 1, that is 3 upon 2, divided by the new power 3 upon 2, minus 5 upon 2 times x to the power of 3 upon 2 plus 1 is 5 upon 2, divided by 5 upon 2. We don't need to write plus c over here because it's a definite integral. The lower limit is 4 and the lower limit is 0 and the upper limit is 4. Now let's simplify this. 10 divided by 3 upon 2 is 20 upon 3 times x to the power of 3 upon 2. 5 upon 2 divided by 5 upon 2 is just 1. So it's going to be minus x to the power of 5 upon 2. You're going to plug in the upper limit first. 20 upon 3 times 4 to the power of 3 upon 2 minus 4 to the power of 5 upon 2 minus, when you're going to plug in the answer x value as 0, you're going to get 0. So the lower limit is going to be 0. Just solve this. 4 to the power of 3 upon 2 is 8 times 20 upon 3 is 160 upon 3. 160 upon 3 minus 4 raised to the power of 5 upon 2 comes out to be 64 upon 3. That's our area. All right. Question number 6 is on circular measure. The diagram shows a sector OAB of a circle with center O. So if O is the center of a circle, then OAB is the sector of a circle. The radius is OA or OB. Angle AOB is theta radian, and OP and AP is equal to x. So this makes your triangle OPA the isosceles triangle. This makes your triangle OPA the isosceles triangle. You need to show that the arc length AB is equals to 2x theta times cosine theta. To find the arc length, we are going to use this formula S equals to R times theta, the angle in radian. You need to calculate the radius first. To calculate the radius OB or OA, you need to understand the geometry over here. Since it's an isosceles triangle, so if you drop a perpendicular line from P to the base OA, that this perpendicular line is going to bisect the line OA, and this length is just going to be OA upon 2. Please remember that OA is the radius. So if you come across the value of OA, that is the value of the radius in this for this question. So we have a right angle triangle in front of us. This is a right angle triangle. Angle is theta radian. The hypotenuse is x. You need to find the adjacent length. So you're going to use cosine theta ratio. Cosine of the angle theta is equals to adjacent, that is OA upon 2, divided by the hypotenuse. So OA is going to be 2x times cosine theta. So if you know the radius now, that is 2x times cosine theta, and when you multiply it by theta, you get 2x theta times cosine theta. This is your arc length. The second part says, find the area of the shaded region APB in terms of theta, x and theta. So shaded region is this region. We need to find this area. So the thought process should be to find the area of the sector minus the area of the triangle OPA to get the area of the shaded region. So I'm going to write this over here. Area of shaded region is equal to area of sector OAB minus the area of triangle OPA. Now, area of the sector is given by the formula half times r square theta. The radius came out to be 2x times cosine theta, half r square times the angle theta, minus the area of the triangle. Now, it was an isosceles triangle. So what we can do is we can find the perpendicular length using the trig ratio. You can find the perpendicular length and then just use half multiplied by base times height. That is one way to go about it. That is one way to go about this question. Or if you know that this angle is theta, this angle is theta, so this angle is going to be pi minus 2 theta. Once you know this angle and these values of x, the length, you can use half into AB sine theta to calculate the area of the triangle. Both can be done. So, area of the triangle OPA would be half times x square times sine of the angle. This angle OPA is going to be pi minus 2 times theta. Let's see if we can simplify this further. So that's going to be 2 times x square theta cos square theta minus half x square sine of pi minus 2 theta. That can be one of the answer. Let's see if that can be further simplified. We have the area of the sector in the simplified form minus the area of the triangle.
Can you take out 2 cos and then sine theta?
Sorry, come again.
Can you take out the, because wait, oh wait, no, never mind.
Okay, we can leave the answer till here.
Okay.
For now. Okay, so question number 7 says, by first expanding cos theta plus sine theta the whole thing square, find the 3 solutions of the equation cos theta plus sine theta whole thing square equals to 1. First, we need to expand this. So using the identity, it's going to be cos square theta plus 2 times cos theta sine theta plus sine square theta. And this is going to be 1 plus 2 times cos theta sine theta. Okay.
Yeah.
Now the question says, solve this equation. So cos theta plus sine theta the whole thing square is equals to 1. This is the equation we need to solve. We can replace cos theta plus sine square theta by 1 plus 2 cos theta times sine theta. And you can see that 1 and 1 is going to be cancelled out. 2 cos theta times sine theta equals to 0. 2 cos theta sine theta is equals to 0. So cos theta is equals to 0 and sine theta is equals to 0. So cos theta is equals to 0. You can find the angles. We need to find the angles between 0 and pi. So one value, cos theta is positive in the first and the fourth, but it's 0 over here. So if you take the basic angle out by doing cos inverse of 0, make sure your calculator is in radian mode. So one of the angle for theta is going to be pi upon 2. If you do cos inverse of 0, the basic angle is going to be pi by 2. And sine theta is equal to 0. So that's going to be theta equal to 0. If you take sine inverse of 0, that is going to be theta equals to 0. And the other angle is going to be pi minus 0, that is pi. So the 3 angles for theta would be 0, pi by 2, and pi. These are the 3 solutions for the first part. In the second part, they say, hence verify that the only solution of the equation cos theta plus sine theta equals to 1 for theta greater than equal to 0 and less than equal to pi are 0 and half pi. So we need to verify. If we need to verify, then we are just going to plug in these values in the equation. So the equation was cos theta plus sine theta the whole thing square equals to 1. So cos theta plus sine theta the whole thing square equals to 1. If you want to verify that the only solutions are these, let's just plug them in the equation. So if we take 0, cosine of 0 plus sine of 0 the whole thing square, cosine of 0 is 1 and sine of 0 is 0. So 1 plus 0 the whole thing square, that is 1. And when you take theta as pi by 2, then cos of pi by 2 plus sine of pi by 2, the whole thing square. Cosine of pi by 2 is 0. Sine of pi by 2 is 1. So when you square it, you get 1. However, if you would have taken theta value 0, if you would have taken theta value to be pi, we will not have, this value will not satisfy the equation. Let's verify this. So cosine of pi plus sine of pi, the whole thing square. Cosine of pi is -1. Just a second. Okay, my bad. The question says cos theta plus sine theta is equal to 1. Okay, not the square. So I'm just removing this square over here from here. Please correct this. Cos theta plus sine theta, cosine of 0 plus sine of 0 is 1 plus 0, and 1 plus 0 comes out to be 1. So that means it is satisfying this equation. Similarly, on the right hand side, when you take theta as pi by 2 and try to find cosine of pi by 2 plus sine of pi by 2, the value comes out to be 1. However, if you take theta as pi, so cosine of pi plus sine of pi, cosine of pi is -1, sine of pi is 0. So when you add this, you get -1, okay, which is not equal to +1. So clearly pi is not the solution, and 0 and pi by 2 are the solution for this equation. Now, in 7 part B, we have been asked to prove the identity. So we can just pick up the complex side and simplify it and show that it is equal to the other side. We can pick the left-hand side because that can be simplified further. Sine theta upon cos theta plus sine theta plus 1 minus cos theta upon cos theta minus sine theta. You can see that the denominators are in the form of a plus b times a plus b and a minus b. So if you make the denominators common, it's going to be cos theta plus sine theta times cos theta minus sine theta. This fraction is going to be multiplied by cosine theta minus sine theta. This fraction is going to be multiplied by cosine theta plus sine theta. So sine theta times cos theta minus sine theta plus 1 minus cos theta times cos theta plus sine theta. Now let's simplify the numerator. Sine theta cos theta minus sine square theta plus cos 1 times cos theta plus sine theta is cos theta plus sine theta, minus cos theta times the bracket is going to be minus cos square theta minus cos theta sine theta. So sine theta cos theta and minus cos theta sine theta can be eliminated. The denominator is in the form of a plus b times a minus b, which is same as a square minus b square. So if we factorize this, we can write cos square theta minus sine square theta. Now let's simplify the numerator once more. We have minus sine square theta minus cos square theta plus cos theta plus sine theta divided by cos square theta minus sine square theta. Now notice the question. In the question, we don't have any cos square term in the denominator. So cos square term needs to be replaced with 1 minus sine square theta. So instead of writing cos square theta in the denominator, I'm going to write 1 minus sine square theta because the identity was cos square theta plus sine square theta equals to 1. So cos square theta can be replaced with 1 minus sine square theta. Now let's simplify this further. If we take minus sine common from here, it's going to be minus times sine square theta plus cos square theta. And we know that the identity sine square theta plus cos square theta is actually 1. So I can just write minus 1 over here. The numerator is going to be plus cos theta plus sine theta divided by 1 minus sine square theta minus sine square theta is minus 2 sine square theta. So the final answer would be if sine theta plus cos theta minus 1 divided by 1 minus 2 sine square theta. All right. Now, part C says using the result of A, part 2 and B, solve the equation. So sine theta upon cos theta plus sine theta minus 1 minus cos theta upon cos theta minus sine theta. This is basically identical to the one we have shown over here. That is cos theta plus sine theta minus 1. So I'm going to replace this by writing cos theta plus sine theta minus 1 divided by 1 minus 2 sine square theta. Okay. So the left hand side is actually equal to this. We have shown it. And the right hand side they have given us is 2 times cos theta plus sine theta minus 1. So if you consider the numerator on the left hand side and on the right hand side, they are identical, so they can be cancelled out. So now you're going to be left with 1 in the numerator divided by 1 minus 2 sine square theta equals to 2. So 1 equals to 2 times 1 minus 2 sine square theta. 2 minus 4 sine square theta equals to 1. 4 sine square theta equals to 1. And sine square theta equals to 1 upon 4. If sine square theta is equals to 1 upon 4, then sine theta would be equal to plus 1 upon 2 and sine theta would be equal to negative 1 upon 2. Okay, now if we solve this further, sine theta is equals to half. So the angles over here, we just need to find the angles between from 0 to pi. So sine theta has a positive value. Sine theta is positive in the first and the second quadrant. And sine theta is negative in the third and the fourth quadrant. But for the third and the fourth quadrant, the issue is that the domain for theta is just restricted from 0 to pi. So you are not going to be having any solutions from here.
Okay.
Okay. Now,
Yeah.
if we solve this equation, to find the basic angle is just going to be sine inverse of 1 upon 2. So sine inverse of 1 upon 2 is going to be pi by 6. If this angle is pi by 6, then the other angle is going to be pi minus pi by 6, which is 5 pi upon 6. So the existing method that we followed was eliminating our answers because we accidentally considered these brackets as an algebraic factors and we just canceled them out. So instead of doing this, because if we cancel this out, we are missing on the angles. So instead of canceling them out, we should have just taken them on the other side. So I'm just going to redo the working over here. All right, so I was saying that instead of canceling these out and missing out on the angles, what we should do is we should take this term on the other side and then take it out common. So the correct working should be cos theta plus sine theta minus 1 divided by 1 minus 2 sine square theta minus 2 times cos theta plus sine theta minus 1 equals to 0. So here we have this bracket and this bracket, which is the same. So we can take this common out. So cos theta plus sine theta minus 1 times 1 upon 1 minus 2 sine square theta minus 2 equals to 0. Cos theta plus sine theta minus 1 would remain as it is. Now, if we simplify this, 1 minus 2 sine square theta, 1 minus 2, it's going to be, this 2 is going to be multiplied by the denominator 1 minus 2 sine square theta. Let's do the working on the other page. So this means that this is equal to 0 and this is equal to 0. So I'm going to write cos theta plus sine theta minus 1 equals to 0. And if we simplify this over here, that's going to be 1 minus 2 plus 4 sine square theta divided by 1 minus 2 sine square theta equals to 0. This is going to give us minus 1 plus 4 sine square theta equals to 0 when you multiply, cross multiply. So sine square theta equals to 1 upon 4 sine theta would be equal to plus minus 1 upon 2. Sine theta equals to 1 upon 2 and sine theta equals to negative 1 upon 2. The problem with this is that theta was lying between 0 and pi. So sine theta is negative beyond pi. So it won't give you any correct values of theta for the given domain. For this, the basic angle is going to be pi by 6. If we take sine inverse of 1 upon 2, that's going to be pi by 6. So the two values of theta are pi by 6. And this value is going to be pi minus pi by 6, that is 5 pi by 6. So these are the two solutions from here. And the two solutions from here would be, the question has given us the hint that using your answer to A part 2, in A part 2, we knew that the correct answer for this equation are 0 and pi by 2. So it's the same equation, cos theta plus sine theta equals to 1. And the two solutions were 0 and pi by 2. So in total, there are four values of theta, that is 0, pi by 6, pi by 2, and 5 pi by 6. These are the four correct solutions. Now, in question number 8, we have been given a function. The graph of the function is already drawn. The function is 3 plus 2 sine 1/4 of x. The domain is given. On the diagram above, sketch the graph of the inverse function. The inverse function is just a reflection of the function in the line y equals to x. So the first thing that you need to do is draw the line of y equals to x. And after that, you're going to just reflect the graph. So this point is just going to be reflected over here. The two graphs will always intersect at the line of y equals to x. If this point is 2 pi and a bit above 3 pi by 2, then the reflection of this point would be just above 3 pi by 2 comma 2 pi, which is this point. So it just have to be a good reflection. Okay, that's the reflection of the function. Now the next part says find an expression for the inverse function. So f of x is equal to 3 plus 2 sine 1/4 of x. To find the inverse function, we have to make x the subject. So that's going to be 2 sine 1/4 of x equals to 3 minus y minus 3. Sine of 1/4 of x is going to be equal to y minus 3 upon 2. 1 upon 4x would be equal to sine inverse of y minus 3 upon 2. And x would be equal to 4 times sine inverse of y minus 3 upon 2. Now, as a last step, what you can do is you can swap the values of x and y. So y is going to be equal to 4 sine inverse x minus 3 upon 2. And your inverse function would be f inverse of x equals to 4 sine inverse x minus 3 upon 2. So that's the inverse function. In part C, we have been given function g, 3 plus 2 sine half x. And this function is defined from minus 2 pi to 2 pi, but they have only shown the graph from 0 to 2 pi. Complete the sketch of the graph of g of x on the diagram above and hence explain whether the function g has an inverse or not. So this function is just drawn from 0 to 2 pi right now. We have to complete it from 0 to negative 2 pi as well. And it's just a sine wave. So it needs to be completed 3. So this point is 2 pi comma little bit above 3 pi by 2. So we just need to complete this over here. That's going to be, if you keep on continuing the graph, it's going to be something like this. So I'll just make it a proper graph. It's just going to be like this. Now the graph has been completed. Now it's asking for a reason, explain whether the function g will have an inverse or no. So you're going to say yes, it does have an inverse. And the reason is that it's a 1-to-1 function. 1-to-1 function. As you can see over here that It's a one-to-one function. If you pass a vertical line, it's only going to intersect the curve at only one point. So it's a one-to-one function. Part D says, describe fully a sequence of 3 transformation which can be combined to transform the graph of y equals to sine x to the graph of y equals to f of x, making clear the order in which the transformations are applied. Okay, so from 0 to pi by 2, the sine x graph would look something like this. Now, from this graph, how do we obtain y equals to f of x graph? F of x graph is this graph. So there are a series of transformations involved. That's the function. We're just going to, I'm just copying down the function over here. This is f of x. And you have to go from y equals to sine x to this function. So there are going to be series of steps involved, series of transformations, and those are the 3 transformations. You need to list down the 3 transformations, and you need to describe the transformations. If you focus that this value is, initially this value was x, and now it has been transformed to 1/4 of x. So that is basically your horizontal stretch with the stretch factor of 4. Okay, horizontal stretch, by horizontal stretch I mean that stretch in the x direction, and the stretch factor is going to be 4. Then once you have gone from sine x to sine of 1/4 x, now you can multiply it by 2. So the amplitude gets multiplied, so the function gets multiplied by 2. It is the vertical stretch. So the second transformation is the vertical stretch with stretch factor of 2. And then you can add 3 to your function. Adding 3 is just like saying vertically translating. So the third transformation is vertical translation. And you can write the translation vector, that is 0, 3. Now the next question is on a series geometric progression. The second term of a geometric progression is 16. The second term in the geometric progression is always equal to AR, which is equal to 16. And the sum to infinity is given to you as 100. You need to find the 2 possible values of the first term. Sum to infinity is equal to A upon 1 minus R, and AR is equal to 16. So we can replace R with 16 upon A and just substitute it over in the second over here. So A would be equal to 100 times 1 minus 16 upon A. If you make the denominator common, that's going to be 100 A minus 16 100 upon A equals to 8. So that's A square equals to 100A minus 1600. A square minus 100A plus 1600 equals to 0. You will have to solve this quadratic equation. So A value comes out to be 80 and 20. That was the first part. The 2 possible values of A are 80 and 20. Now the second part says, show that the nth term of one of the 2 possible geometric progression is equal to 4 to the power of n minus 2 multiplied by the nth term of the other geometric progression. Yeah. So the question is, show that the nth term of one of the 2 possible geometric progression is equal to 4 to the power of n minus 2 multiplied by the nth term of the other geometric progression. So which 2 geometric progression are they talking about? They are saying that when A is 80, R would be a different value, and when A is 20, R would be a different value. So when A is 80, just let's plug in A as 80 over here. So 16 divided by 80 is 1 upon 5. And 16 divided by 20 is 4 upon 5. So the 2 geometric progressions are 80 times 1 upon 5 to the power of n minus 1. And the second progression would be 20 times 4 upon 5 to the power of n minus 1. So we need to show that the nth term of one of the two possible geometric progression is equal to 4 to the power of n minus 2 multiplied by the nth term of an arithmetic progression. So what we need to do is we just need to take the ratio of these two progressions. So let's say I'm calling this as my geometric progression 1 and this is my geometric progression 2. So I need to show that one of the geometric progression is going to be equal to 4 to the power of n minus 2 times the second geometric progression, which is same as saying that the ratio of the two geometric progressions should be equal to 4 to the power of n minus 2. So I'm going to divide both the geometric progression g1 over g2. So that's 80 times 1 upon 5 to the power of n minus 1 divided by 20 times 4 upon 5 to the power of n minus 1. 80 upon 20 is 4 times, okay, 1 upon 5 to the power of n minus 1 is same as saying 1 upon 5 to the power of n divided by 1 upon 5. And this answer was being divided by 4 upon 5 to the power of n minus 1, which means 4 upon 5 to the power of n divided by 4 upon 5. This was being divided. So we get 4 divided by 1 upon 5. 4 divided by 1 upon 5, that's going to be 20. 20 times 1 upon 5 to the power of n. You can reciprocate this, and you're going to get 4 upon 5 to the power of 4 upon 5 to the power of n. So 20 times 4 upon 5 is 16. And 1 upon 5 to the power of n divided by 4 upon 5 to the power of n is same as 1 upon 5 divided by 4 upon 5 to the power of n. And 1 upon 5 divided by 4 upon 5 is 1 upon 4. So the question said that to represent this in the form of 4 to the power of n minus 2. So I'm going to convert 16 as 4 square, and this is going to be 4 to the power of minus n. So if you add this, when the bases are same and are being multiplied, when you add this, you get 4 to the power of 2 minus n, which is, okay, 4 to the power of, it should be 4 to the power of n minus 2. Okay, which is 4 to the power of 2 minus n. Okay, right now.
Yeah.
So first geometric progression divided by second geometric progression is this. So second geometric progression divided by first geometric progression would be the reciprocal of this, which is just going to be 1 divided by 4 to the power of 2 minus n. Now, if you rewrite this, it's going to be 4 to the power of negative 2 minus n, which is 4 to the power of n minus 2. It's the same thing, but it's just going to be written as a different form.
Yeah, you can move on.
Okay. The equation of a circle is x minus a the whole thing square plus y minus 3 the whole thing square equals to 20. The line y equals to half x plus 6 is tangent to the circle at the point P. Show that one possible value of a is 4 and find the other possible value. Okay, so we have the equation of a circle. We need to show that one possible value of a is 4. If that is what we need to show, then why can't we just plug in a as 4 and see whether the left hand side and the right hand side comes out to be the same? Okay. The equation of a circle is given. The line is tangent to the circle at the point P. We need to show that one possible value of a comes out to be 4. Okay, so line is tangent to the circle.
Yeah.
This is the point P. The center coordinates are a comma 3. Now we have the equation of a line y equals to half x plus 6. So if we substitute or if we solve the two equations simultaneously, the equation of a circle is x minus a the whole thing square plus y minus 3 the whole thing square equals to 20. Equate the two equations together. Plug y as half x plus 6, x minus a the whole thing square plus half x plus 3 the whole thing square equals to 20. You're going to get an equation in terms of a. So that's going to be x square plus 2ax minus plus a square, x square minus 2ax plus a square plus 1 upon 4x square plus 3x plus 9 equals to 20. X square plus 5 upon 1 upon 4x square is 5 upon 4x square minus, it's going to be plus 3 minus 2ax. Collect the x terms together, plus a square minus 11 equals to 0. 9 minus 20 is minus 11. Now, if the line is tangent to the circle, then the discriminant of this equation should be equal to 0. So b square minus 4ac should be equal to 0 because the line is tangent to the circle. B value is 3 minus 2a. A value is 5 upon 4. C value is a square minus 11. Let's expand this now. So we need to show that one of the value of a is 4. So when you are going to plug in a as 4 over here, 3 minus 8, the whole thing square, minus 4 times 5 upon 4. 4 square is 16. That's 25. 16 minus 11 times 5 is 25, and you're going to get 0. So this is how you're going to show that a equals to 4 is one of the possible value. And to find the other possible value, we are just going to solve this equation. That's going to be 9 minus 12a plus 4a square minus 5 times a square minus 11 equals to 0. 4a square minus 12a minus, let's just simplify this further. 9 minus 12a plus 4a square negative 5a square plus 55 equals to 0. Minus a square minus 12a, 55 plus 9 should be 64. So a square plus 12a minus 64 equals to 0. If you solve this equation, one value of a would be 4, but we are interested in the other value now. A value is 4 and the other a value is minus 16. So the other value is minus 16 over here, and one of the value of a was 4. Okay?
Yeah.
This was part A. Then the question says for a equals to 4, find the equation of the normal to the circle at P. We already had the equation of tangent to the circle at P. The equation of the tangent was y equals to half x plus 6. We have the coordinates now for the center of the circle. A value is 4. So the coordinates of the center of the circle is 4, 3. We need to find the equation of tangent to the circle at point P. So the gradient of the tangent line, the gradient of the perpendicular line is going to be, the gradient of the tangent is 1 upon 2. So the gradient of the normal is going to be minus 2. It's negative reciprocal. And the point is 4, 3. So y minus y1 equals to mx minus x1. Y minus 3 equals to negative 2x plus 8. Y equals to negative 2x plus 11. So the equation is y equals to, y equals to negative 2x plus 11. That is the equation of normal. Then the third part says for a equals to 4, find the equations of the two tangents to the circle which are parallel to the normal found in B. So if we just copy this down and review the question again, find the equation for a equals to 4, find the equation of the two tangents to the circle which are parallel to the normal found in part B. So we have the equation to the normal now. The equation of the normal line is y equals to negative 2x plus 11. We need to find the equations of two tangents to the circle which are parallel to the normal. Equation of two tangents that are parallel to the normal. So parallel means that they will be having the same gradient. They are parallel. So they are parallel. So the gradient for both the tangents are going to be -2. But we need to find the equation of the two tangents. Any suggestions? So what we can do is, we know that the gradient of the parallel line is the same. So if the normal has a gradient of -2, then this line will also have a gradient of -2. So the equation is going to be y equals to -2x plus c. Now, we don't know this c, the constant of integration. So what we can do is, we have the equation of a circle. The equation of a circle is going to be x minus 4 the whole thing square plus y minus 3 the whole thing square equals to 20. We can solve this equation and the circle simultaneously. We know that the gradient was -2. And if the line is parallel to the normal line, the equation is going to be of the form y equals to -2x plus c. So over here, in place of y, I'm going to be substituting that -2x plus c minus 3 the whole thing square equals to 20. X square minus 8x plus 16 plus, if I expand this, it's going to be a square minus 2 times a square plus 2 times a times b plus b square. So x square minus 8 plus 16, that's going to be 4x square minus 4x times c minus 3 plus c minus 3 the whole thing square, x square minus 8x plus 16, 4x square minus 4cx plus 12x plus c minus 3 the whole thing square, x square minus 8x plus 16 plus 4x square minus 4cx plus 12x plus c minus 3 the whole thing square minus 20 equals to 0. Now 4x square plus x square is 5x square. 12x minus 8x is again 4x plus 16. This is 4x and minus 4cx plus 16 and minus 20 is going to be -4 equals to 0. Okay, so this is the equation that I am getting. It's going to be 5x square plus 4 minus 4cx. Now I'm getting it correct.
Is that the correct equation?
Yeah,
I
this
got
one is the
something
correct one. Now we are going to apply the concept of discriminant. We know that the line is tangent to the circle. So 4 minus 4c the whole thing square minus 4 times a times c minus 3 the whole thing square minus 4 equals to 0. So that's going to be 16 minus 32c plus 16c square minus 20 times c minus 3 the whole thing square minus 4. Have to simplify this further. Sixteen minus 32c plus 16c square minus 20 times c square minus 6c plus 9 minus 4 equals to 0. Minus 4c square minus 32c This should be plus 120c plus 16 minus 100 equals to 0. So negative 4c square plus 88c plus 84 equals to 0. And when we solve, we are going to get the two values of c. This one. So minus 4c square, 88. This should be minus 84. So the two values of c comes out to be 21 and 1. This means that the equation of the two tangent lines are going to be y equals to minus 2x plus 21 and y equals to minus 2x plus 1. Please check the working. All right, now question number 11 says, the equation of the curve is y equals to k times square root of 4x plus 1 minus x plus 5, where k is a positive constant. You need to find the derivative of y with respect to x. So dy by y is basically equal to k times 4x plus 1 to the power of half minus x plus 5. dy by dx would be k times half, that is k upon 2, 4x plus 1, reduce the power by 1, so half minus 1 is minus half, times the differentiation of 4x plus 1, that is 4. Differentiation of minus x is minus 1 and differentiation of constant term is 0. So dy by dx is 2k times 4x plus 1 to the power of minus half minus 1. Now the second part says find the x coordinate of the stationary point in terms of k. So to find the stationary point, we are going to set dy by dx expression equal to 0. 2k times 4x plus 1 to the power of minus half minus 1 equals to 0, which means 2k upon 4x plus 1 to the power of half equals to 1. 2k would be equal to 4x plus 1 to the power of half. Now to get rid of this half as a power, you're going to square both the sides. You're going to get 4k square equals to 4x plus 1. So to make x the subject, you're going to get 4k square minus 1 divided by 4. Okay.
Yeah.
Now the last part says, given that k is 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of 10 inverse 2 with the positive axis. So you need to find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of 10 inverse of 2 with the positive x-axis. Let's say this is the tangent line to the curve, okay, whatever the curve is. This tangent line makes an angle of tangent inverse of 2. So if the angle is tangent inverse of 2, then tangent theta would be equals to 2, which means that the gradient is 2. Gradient of the tangent line is 2, which means that the value of dy by dx is 2. dy by dx is 2. Now, dy by dx was, okay, the normal to the curve, so the tangent makes this angle with the positive x-axis, but we need to find the equation of the normal. The gradient of the normal line would be minus 1 upon 2. Just remember that. Okay. So dy by dx expression is here. You're going to equate it to 2. K value is given to you as 10.5. So 10.5 times 2 is 21. 21 equals to 3 times 4x plus 1 to the power of half. You're going to square both the sides. 21 square is 441. 3 square is 9 times 4x plus 1. 36x plus 9 equals to 441. 441 minus 9 divided by 36. X comes out to be 12. So it's the x value. The point where the tangent line was being made is 12. X is 12. To find the y coordinate, we can just plug the value back in the equation. The equation is given to us over here. So y equals to k, that is 10.5 square root 4 times 12 plus 1 minus 12 plus 5. So let's work out this value. 4 times 12 plus 1 is 49. Square root of 49 is 7. 7 times 10.5 is 73.5 minus 12 plus 5. That is 66.5. So the coordinates are 12, 66.5. We know that the gradient of the normal line is minus 1 upon 2. So we can find the equation of the normal line. That is y minus y1 equals to m x minus x1. So 2y plus x equals to 133 plus 12 is 145. Okay.
Yeah.